Okay, so let's take a look at your homework. It's on the stuff from page 678. So the first one I asked you to do was number 46, which has 2-point charges, positive 8, negative 5 microcoulombs placed 10 centimeters apart in a vacuum. What location along the line between their centers will the electric potential difference be 0? So it's like the one we did yesterday in class. Okay, so there's some point between these two where, if we call this one number 1 and this one number 2, where V1 plus V2 will equal 0. It has to be closer to the smaller one. So this will be R1 and this will be R2, but R2 will really be equal to 10 centimeters minus R1. So then when we go here, it'll be KQ1 over R1 will equal negative KQ2 over R2. The K's will cancel, and R2 is really just 10 centimeters minus R1. So we'll have Q1 over R1 is equal to negative Q2 over 10 centimeters minus R1. So now you cross multiply. Q1 10 centimeters minus R1 is equal to negative Q2 R1. Multiply through the bracket, so Q1 10 centimeters minus Q1 R1 equals negative Q2 R1. Bring the R1s to one side, so Q1 10 centimeters is equal to Q1 R1 minus Q2 R1. Pull out your R1, so Q1 10 centimeters is equal to R1 Q1 minus Q2, and now divide by this. So R1 is equal to Q1 over 10 centimeters divided by Q1 minus Q2. And so now just fill in your values. I called my Q1 the 8 microcoulombs. So 8 microcoulombs times 10 centimeters over 8 microcoulombs minus a minus 5 centimeters. So on the top I get 40 microcoulomb centimeters, and on the bottom I get negative 13 microcoulombs. And when we divide 40 by negative 13, well, it's not really 40 though, it's 80, right? Okay, looks like there's something wrong. 80 divided by negative 13, you get 6.1538 centimeters for R1, and then R2 is 10 centimeters minus that, so 3.8462 centimeters. This one would be towards number 2 would be the direction, and this one would be towards number 1, so that it ends up in the middle. Okay, so that's the point in between them. As we talked about in class, though, there's actually a second point. And the second point's always on the side of the smaller one, regardless of the sign. So yesterday it was on the side of the positive one because the positive one was smaller in magnitude. Today it's going to be out here on the side of the negative one because the negative one is smaller in magnitude. So there's a second point out here, and if we call this distance x, then R2 is going to be equal to x, and R1, new R1, is going to be 10 centimeters plus x. And again, it'll be V1 plus V2 equals 0, or KQ1 over R1 will equal negative KQ2 over R2. Again, the K's cancel, and this time it's Q1 over X is equal to negative, whoops, that's not right though, it's Q1 over 10 centimeters plus X is equal to negative Q2 over X. Cross multiply, Q1 times X is equal to negative Q2 10 centimeters plus X. And maybe just to go back to where I did the oops, The R1 is bigger. It has to be the 10 centimeters plus X. It's closer to the R2. If you screw it up the way I almost did, you'll end up getting a negative answer. And that negative answer is trying to tell you you put it on the wrong side. Okay, so we now multiply through by the brackets. Q1x is equal to negative Q2 times 10 centimeters minus Q2 times x. Take this guy over. Q1x plus Q2x is equal to negative Q2 times 10 centimeters. Pull out the x. Q1 plus Q2 equals negative Q2 times 10 centimeters, and divide. So x is equal to negative Q2 times 10 centimeters over Q1 plus Q2. Fill in your numbers. A negative 5 microcoulombs times 10 centimeters. That's positive 50 on the top. And on the bottom, 8 microcoulombs plus a minus 5 microcoulombs. So that's going to be positive 3 on the bottom. So 50 divided by 3 should give you 16.6 repeating centimeters. And then 10 centimeters plus that. This is really, sorry. This is R2. And then R1 is 10 centimeters plus that, so 26.6 repeating centimeters. This one is opposite side as Q1. So it's on the other side of Q2, not on the Q1 side. And this is towards Q2, because it's on that side. Just beyond, it'll end up being beyond. Okay, so that's how you find your 2 points. All right, the next question I asked you to do was number 49. And 49 gives us 3 charges on 3 corners of a square. And it wants to know the electric potential difference at point M, the midpoint of the diagonals. So right here. So we know these two lengths are 6 centimeters, or 0.06 of a meter. Okay, and so from that you can find the full length of the diagonal by doing the Pythagorean theorem. So if you do 0.06 squared, and that should be 0.0036, multiply it by 2, take the square root, and then you'll get this whole length, and it ends up being 8.486 or something like that. 8.486 meters. But we only want half that distance. So 4.243, I think. I would check it, but my calculator has decided not to work, so I'm going to hope I'm doing it right in my head. Oh, that's really centimeters, not meters. Sorry, I couldn't do this meters in my head. All right, so now what do? You do VA. You find the potential from A at this point. So VA will equal QK over R. Then you do VB, which will be equal to KQB over R. And then you do VC, which will be equal to KQC over R. Okay, so 9 times 10 to the 9th Newton meter squared per coulomb squared times the Q, which was 2 microcoulombs, -6, divided by 0.04243 meters. The same down here, except the numbers here change to 4 times 10 to the -6. And this one is -8 times 10 to the -6. Running out of video, that's why I'm rushing. So you should get, for these 3 V's, 4.24264 times 10 to the 1, 2, 3, 4, maybe 5 volts. And this one should be, oh, maybe both of these were negative, were they? Negative 8.48456 times 10 to the 5th volts, and this one negative 1.696912 to the 6 volts,